welcome to the first Methods 12 help video. I'll be doing more like this as we go through and hopefully guided by the questions that you have. I thought we'd start the year with looking at solving trig equations. If you can master that, you'll have just as much as an edge in your methods exam as the specialist students have, and ultimately that's what you want to try and do. So I thought we'd go through solving two equations. After I've gone through the bit of intro, it'd be great if you pause the video, try the first equation yourself, watch the solution, and then the second one yourself and watch the solution, just so you get a little bit more out of it than just listening to me go through it. The first thing to do is we need to have a look at our table of exact values for sine, cos, and tan. I've put there the degrees and the radians, but really this sort of table is something that I really always recommend that by now in year 12, after hopefully using it for 2 years, you actually already know off by heart, but I'll just show you a few little tricks that might help you remember it. If you can memorize the line of exact values for sine, then you'll be able to easily fill in cosine and also tan. So let's look at how we go. So the sine values increase. So sine of 0, whether degrees or radians, is 0. Sine of 30 degrees or pi on 6 is a half. And then when we're looking at 45 or pi on 4, we have 1 on root 2. And then we have root 3 on 2 and 1. Okay, you can get those and devise those from the triangles, and that's fine also. Just depends whether you want to memorize the triangles and deduce those values, or to be a little bit faster this year, just know them, and that's what I recommend. For cosine, it's exactly the same as sine, but decreasing. So we have 1, root 3 on 2, 1 on root 2, a half, and 0. So if you know sine, you already know cosine. And then looking at tan, tan is always sine divided by cosine. So you can work these ones out as well. So 0 divided by 1 is 0. If we're looking at a half divided by root 3 on 2, you know that you have a half times the 2 on root 3 flipped, and the 2's cancel out. So you end up with 1 on root 3. 1 on root 2 divided by 1 on root 2 is just 1. This one becomes root 3, and this one is undefined, so we can write does not exist. Okay, so you need that table of values to be able to solve an equation. So let's take a look at the first one. Again, you might like to pause now, try it yourself, and then watch the answer. If we're going to solve this equation, the first thing we need to do is just have it sine x equals. So that's a first easy step. Sine x is equal to negative root 3 on 2. Okay, so that's ready to go, and you'll recognize that from our table. The next thing to do is to draw a sketch of your unit circle. So you want to ask yourself, where is sine negative? And sine is negative in the bottom 2 quadrants. So you can just draw yourself 2 lines. And then for what value in radians do we get sine equal to root 3 on 2? So you can look at your table now, but hopefully you'll memorize it. It's pi on 3. So we can put that in our unit circle. Okay. That's the main thing. Now we need to understand the domain that we've been presented with. So this is the domain between negative pi and 2 pi, inclusive because of the square brackets. So what we want to do is follow that around. So the first thing we can do is let's do the negative part first. So we're going from 0 to negative pi. Okay, so what we end up with is our first answer of x is equal to negative pi on 3, because we just passed that. Okay, so that's here, negative pi on 3, and then the very next one would be negative 2 pi on 3. Okay, you can just count around the lines, and of course over here at negative pi, we could call that negative 3 pi on 3. So the first two answers are negative pi on 3 and negative 2 pi on 3, and you can write them in ascending order if you like, or just as I've done there. Now, we also want to do the positive value, so starting at 0 and going around to 2 pi, so a full circle. Okay, so the ones we didn't pass, as in they're not in our diagram, we would have pi on 3, we would have 2 pi on 3, 3 pi on 3, and then the first blue line that we would actually pass is 4 pi on 3. And the next one, 5 pi on 3. And if we came back to the beginning, or back to the 2 pi, we could call that 6 pi on 3. Okay, so the other answers to add are 4 pi on 3 and 5 pi on 3. And hopefully those are the answers that you got when you had a go. So let's try the next one. And again, you might like to pause and give this one a go, especially now you've seen question 1, and then we'll have a look. Okay, so again, to start with, we want it to be tan x by itself. So if we take the 4 to the other side, we just get tan x is equal to 1. Then we'd like to draw a sketch for our unit circle. So where is tan positive? And why are we asking for positive? Because the 1 is positive. So tan is positive here and here. And for what value in radians do we get tan of that value is 1? It's pi on 4. So pi on 4 and pi on 4. And now we need to use our domain, follow it around, and see what values we get. So again, let's do the negative part first. So let's go from 0 around to negative 2 pi. Okay, so that's just going clockwise around. So if you're not sure of what those values would be, add in the ones that aren't there or aren't drawn in our diagram. So this would be negative pi on 4. And then splitting it into quarters, this would be negative 2 pi on 4. And so this one is negative 3 pi on 4, and that's one of our answers. You'd have negative 4 pi on 4, and then negative 5 pi on 4, negative 6 pi on 4, and then the one we want, negative 7 pi on 4. So there's your first 2 answers. We've got negative 7 pi on 4, and also negative 3 pi on 4. Now we'll just do the same, but for the positive part, which is from 0 to pi. And you can see we only pass one of our blue solutions that we've drawn, and that's just the pi on 4. So that one's really easy to count because it's the very first one. And that is all the solutions that exist within that domain. So hopefully that gives you a nice little refresher on some skills you definitely need to be really good at this year.